So here we have another example for graphing, but this time we're not given the actual function f of x, but rather we're given f prime of x, which is 2x squared minus x cubed. And the question is to use techniques of calculus to give a rough graph and also to state all important points along this graph, such as max, min, inflection points, and so forth. So we don't really need f of x to do a rough graph. To get the general shape, it's sufficient to begin with f prime. So step number 1 was to set f prime equal to 0. Let's solve this for x. So I'm going to take out an x squared from both of the terms. And setting each one equal to 0, we get x squared, in other words, x is 0, or 2 minus x, in other words, is 0, that is x is equal to 2. So 2 possible critical points here, and again, there is no point where f prime is undefined. If that happens to be the case, that's another source for critical points. In this case, the only source happens to be where f prime is equal to 0, because there is no such point where f prime is undefined. So we're going to put those on the number line, from the smallest to the largest, and try to determine the sign of f prime by picking test values. Test values are -1, 1, and 3. Substitute them into f prime. You see, this x squared over here is always going to be positive, so no matter what you plug in, that's going to be positive. But then the 2 minus x, that's like 2 minus -1, so that's also positive. The end result is positive. So let's do this for the other numbers as well. Plug in 1. And then we plug in 3. So f prime is positive first, positive again over the second region, and negative in the last region. What does that tell me about the graph itself? Remember, from f prime you get information about increasing or decreasing nature of the graph. And since it's positive and positive in these two bordering regions, I might say that it's just rising over this entire region all the way to 2. All the way from negative infinity to 2 is rising. And then it's going to be falling. Can you already tell me what you think the point x is equal to is going to be on this graph? If you said a maximum, you were correct, because the graph is rising up to that point and then falling afterwards. Okay, let's get information from the second derivative. So for that, we're going to need to find f double prime. Remember, given function was f prime, so you want its derivative. So I took it out from the step, and I differentiated it to get this. And now we set f double prime equal to 0 and solve for x. Once again, we have two values. Here it is going to be 4/3. And we put those on the number line. So here's the f double prime chart. The potential inflection points are 0 and 4/3, which is like 1.33. So I'll put it over here. So I need to do a sign chart for f double prime. Now, should I be putting these points over here? No, right? Because if you put those points, we already know f double prime will be 0 at those points. What we need is test values from between them and outside of them. So for example, here I can pick a 1, I can pick a 2 here, and -1 over here, and put them on this chart, and plug them into this function. So again, you may want to pause the video right now, see if you can finish it, and then come back and check the results. This one turns out to be negative times positive, because 4 minus 3 times negative 1, that's like 4 plus 3, that's positive. The end result is negative. So I'm getting the following signs: negative in this region, positive in this region, and negative in the outside region. So don't draw lines like decrease, increase, because you do not get that kind of information from F double prime. Rather, what kind of information do we get? Concavity, right? So like it's concave down over here, concave up over here, and concave down again on the last region. Since we don't have the original function, we're not going to get y coordinates. Actually, we're pretty much ready to go to the graph. So I'm going to do a number line. I don't know the y coordinates, so I'm not even going to bother putting the y-axis. I will put the important points on here: 0. Let's say this is here's the point 2. Here's the point 1.33 is over here. So according to the graph, the F prime chart, the graph should be rising up to the point 2. Now we don't know how high it's going to go, so that's why this is a rough graph. And after the point 2, it should be falling, right? Based on the chart here. So after 2, it should be falling. This is a very rough graph of what's happening. Now let's add in the concavity information. It's concave down up to 0. Concave down up to 0, but you got to follow the increasing decreasing pattern. So concave down up to here. So rising at the same time, bending inwards. In between 0 and 1.33, it should be concave up. So rising, but concave up. After 1.33, it should be concave down. So everywhere else, follow the general pattern. It has to be rising and falling, but at the same time, it has to be concave down the rest of the way. Maybe I can outline this with a thicker marker. Let's see, that didn't work. So it's rising. It's rising up to x equals to 2. So the maximum, there's a relative maximum at that point. So let's list all the important points. So there is a relative max at the point x is equal to 2. There is no relative min. The function is concave up. Only in this region, right, between 0 and 1.33 roughly. It should be concave up. And concave down everywhere else. Namely, from negative infinity to 0, and from 1.33 to infinity. So there you have it. The second question didn't take us as long, because you will see that this is going to be a very repetitious process. You always take the first derivative, get information out of that as much as you can, then you take the second derivative, and then you put the pieces together in the last part when you're trying to get the graph. Okay, now here is another interesting example. This one's going to be a little bit unusual. for this one, I'm not going to give you guys any functions at all. You'll be having no equations, no f prime, but all I'm going to give you is a sign chart. So let's say that the sign chart for f prime is, it's negative over here, positive afterwards. And the sign chart for f double prime is positive first, negative in between, positive later. And you can assume that f prime is 0 at this point and at this point, and you can assume that f double prime is 0 at this point and at this point. The question is, from this information, can you provide the graph, a rough graph? Again, this may be a good point to pause the video and then come back and take a look at the solution. I will first put all the important points on a single number line. These points mentioned are 0, 2, and 4. From f double prime, we know it should be decreasing up to 4, increasing afterwards. From f double prime, it should be concave up first, concave down later, and concave up again. So first f prime, right? F prime will give us a skeleton. So it makes the graph decreasing up to the point 2. And we don't really know exactly where it crosses the x-axis. We don't know how high or how low it goes, but this is the general shape of the function. After 4, it should be rising. Now put in the concavity information. Concave up to 0. So following the same path, like it should be falling but concave up. Then concave down between 0 and 2. So you should follow the pattern, meaning it should be decreasing and concave down. I'm kind of making these exaggerated. When you look at an actual graph, you might see that these are actually very subtle changes, but I'm really trying to make a point, so I'm exaggerating the graph so you can clearly see the change in concavity. And the last region, it should be concave up. So I'm going to just try to smooth this out a little bit. So up, down. Okay, so already we have a graph for this function, and we can clearly state the minimum, there is no maximum, the inflection points, and so forth.